So yeah, if we have all these different types of classes, but they all have, let's say, obviously all animals have to eat. So they would probably have an eat method. Now you could say every animal eats a little differently, but in this case, let's just say all of them have to eat, okay? And let's just say a drink method. Because all of them need to drink. Yeah, they might drink a little differently, but in our simple example, we're just saying, hey, every animal, every dog, cat, and giraffe all need to drink, and they all need to eat. And basically, if we have all these classes, let's just say we have 100 different animals, 100 different animal classes, and we would have to go in here and code the drink method and the eat method for every single animal. And that's just a lot of code that we have to write that's just unnecessary. So that's where inheritance comes into play. And what you would want is when you're thinking about a design, if you realize, hey, all these classes are using the same exact method, literally copying and pasting into all these different classes. When you have that come up, that's when you're going to want to use an inheritance. That's basically saying, hey, this stuff isn't changing. This dog might bark, meow, and whatever a giraffe does, I don't even know if it makes any noises, but those you wouldn't pull out and put in a superclass, but all of these, drink and eat, are going to all be in dog, cat, and giraffe. And it's basically going to be copy and paste, and etc. for all your classes. So once we find out, hey, these are unchanging behaviors, that's where inheritance comes into play. And you would have a superclass that you would want to put these in. That way, all these classes can inherit these methods, and you don't have to write them out in every single class. So you would have a superclass. This is where you would want to have a superclass. And in this case, obviously it makes sense that all of these are animals, and all animals drink and eat. So animal would be our superclass. And let me finish my arrows here. These arrows are specifically showing inheritance. So you would put drink and eat you would put those in the superclass. This is the superclass. And these are basically the subclasses. Another term would be parent class, kind of parent and kind of child classes in a sense. So instead of writing drink and eat and copying and pasting and throwing in every single class, even though it's the same exact code, that doesn't make sense. That's when we have inheritance. We have a superclass that takes all the methods and members that are shared among all these classes, and it says, hey, if you're an animal, let's use inheritance, and you can just inherit my methods. So the question you always got to ask when you're trying to do inheritance is, it's called a relationship that is a. So you just got to make sure, is a dog an animal? Yes, it is. Is a cat an animal? Yes, it is. Is a giraffe an animal? Yes, it is. If we had a car class, is a car an animal? No, it's not. If we had, what else do I want to say? Like some class where I don't know, maybe it has a walk. It's a walk behavior. Walk is not an animal. So yeah, you want to have the is-a relationship with inheritance. That's what it is. Okay. So like I said, code reuse. We don't have to copy and paste. we say, hey, these methods are in all these classes and they're all the same. So let's not waste our time coding in all these classes. Let's put it in a superclass, and you would use the keyword extends. So giraffe would extend animal, and it would inherit all of its members and its methods. In this case, it would inherit drink and eat. So the giraffe, if you create an object, an instance, if you create a giraffe object, you will have the drink and eat method because it extends animal. Okay. Next topic is going to be, let's do polymorphism. Polymorphism, basically, polymorphism, what does that mean? It basically has many forms. So when you create an object, let's go back to our animal class. And let's go back and create let's just say we have a dog class, okay? So how polymorphism works is basically saying, let's create a dog object, but I want it to have many forms. That means I want to be able to treat this dog object also as an animal object. Because in this animal class, so let's also say I have a cat. Let's pull up the same exact classes, dog and cat. In this animal class, let's say I have an array of animals. So array is a collection. It is a data structure to hold objects. So if I have this array, and I'll just get a little bit more, put some indexes, that way you know it's an array, because an array is always, you can access it by basically the index. So I have, in my animal class, I've constructed this array of animal objects. But let's say I want to add different types of animals, a dog and a cat and all these different types of objects. So if I have another class, like my main, we'll say main method, main class, whatever. This is usually your main method is where you're creating all your objects. Usually all your other classes, that's a good thing that I want to talk about too. Usually you're not creating objects when you're building these classes. That's what your main method is for. That's where the driver code happens and your program executes, and this is where the objects start getting created and your program starts actually running. So let's say in your main class you want to create an object, you want to create multiple different objects, and you want to put them in this animal array. So polymorphism allows you to basically say animal, let's just call this, I'm getting lazy, but A1, that's just the name that we're going to call it, and we'll say equals new. Now usually when we're constructing a new object, we're going to have the type of the class, and then we're going to call the constructor of that class. But what we're going to do in this case is, yeah, it's going to be type animal, but it's also going to be a dog object. So we're going to call the dog constructor. So this is kind of a good example of polymorphism. You're saying, hey, I have this animal array. If I created a dog object, if I said dog A1 equals new dog, and I try to put it in this array, it wouldn't work out. In an array, you have to have all of the same type. But with polymorphism, I can say, hey, I want to create a new dog object, it's going to be of type dog, but it's also going to be of type animal. And I would do the same thing for the cat. So animal A2 equals new cat. So I'd call the cat constructor to create a new cat object, but it's also going to be an animal object. Let's say the animal object has a make sound method, and then dog and cat have a make sound. So obviously a dog and a cat don't make the same sound. A dog would bark, a cat would meow. You would override the make sound method in your dog and cat class to make its own sound. But let's say we created these objects, and now in our animal array we can put A1 in there, we can put A2 in there, and the nice thing is if we had a loop to iterate through our array and all the objects, let's say if we had a cat, a dog, a giraffe, a tiger, but all of them we instantiated with the animal type. Now when we call the make sound method, even though it's of type animal, it's going to say, hey, even though this is an animal object, I can see that it's polymorphic and that this is an actual, not only is it an animal object, but it is a dog object. So I'm not going to call the make sound method for animal, I'm going to call the make sound for dog. So if I had a loop and I said, hey, for every object in this array, call the make sound method, it's not going to cause an error because we use polymorphism. It's going to say, hey, these are all types. They're still animal. They're still of type animal. So it makes it polymorphic, as in you can use, if you didn't have a sound, it would say, hey, okay, I'll use the make sound for animal if you had a default sound. But if the animal does have a sound that they can make, it's going to find that out and say, hey, okay, this is going to bark, this is going to meow. So that's a quick overview of polymorphism. So collections or data structures we could go over. So you'll have different types of data structures that Java has. So it's called so everything in object-oriented is a class. So there's a class, I think it's called collections or collection, and then it has all these subclasses, which is data structures. So you have an array, 0, 1, 2, 3. You have a stack, which this is last in, first out, which basically, it's almost like a stack of plates. If you put a plate on top, let's say you're stacking dishes, clean dishes in your cabinet, you put a clean dish on top, whoever comes next to get a clean plate, they're going to grab the last one that was put on the stack. So that's what stack is, last in, first out, means whatever you put in last is whatever you're going to take out last. And a stack has the two popular methods are pop, which just means, hey, pop off the guy that's on the top, and then push, you're just pushing the guy onto the stack. Array, you don't have a lot of methods for array. It's mainly just accessing the index. So here you can specifically, you don't have to cycle through the list to get to your object. You can say, hey, just grab me the object at position 4. So arrays are nice, but you do have to have all the same type, and once you set the size of an array, you can't change it. You would have to create a new array. and there's ways to do that, but it's a little bit messy. That's why ArrayList is nice, which kind of extends the list class. The list is obviously just a list of stuff, and you're using add functions just to add it to the list. So let's say like a grocery list, you just have items in there, and just basically adding to a list. So an array list is nice because it implements the indexing feature and it implements the list, because in a regular list you can't really randomly access the second to last object in there, but with an array list you can do that. You have that power. You can also use indexing. Say, hey, in my array list, grab me the one at position 4. But with an array list, you can, like, once you create an array, it's dynamic. You can keep adding objects. You don't have to create a new array. It's not fixed. So that's the advantage of ArrayList. And then you're going to have trees. So tree, there's a lot of different types of trees. But trees, I probably should have talked about LinkedList first. Let me do LinkedList. So linked list is basically you would create what are called nodes. There would be usually a class called node, and it would be an object. And basically inside that node class, you would have a pointer, which basically usually would be called next or next node. And you would assign a node object pointing to the next node. So, and also in your linked list class, you would make sure if you created an instance of linked list, if you created a linked list, you want to make sure you keep track of the head. You can always access the head. So basically, to get to these objects, you always have to start at the head. So the head node, and then if you want to go to the next one, you would go, you would check, hey, what inside this object, what is the next node? Where does it point to? And then you would keep following, and that would be a linked list. Tree is kind of the idea of linked list, but instead of just having one node, you would have two nodes. Usually you're going to have a left and a right node, and you could do 3 nodes. I mean, you can go on, but the popular one is just going to be a tree, which it has a left node and a right node, and then obviously you have the head node. And trees are really good for searching, because if let's say if you have a bunch of numbers, you can say, hey, let's say this number, let's just fill this out real quick. 5, 7, and 9, and 6. Okay. And then 3, and 1, and 4. So I don't know if you can see that, but so this is an example of why a tree is good for like searching. So if you had a bunch of numbers in some kind of data structure, a lot of times you might want to use a tree for if you have to search for those numbers, because if I wanted to search to see if there is a number 1 in this tree, I would start at the head and I would say, I'm looking for the number 1. If it's less than this number, it's going to go to the left. If it's larger, it's going to go to the right. So I'm looking for 1. I'm at the node 5. 1 is less than 5, so go to the left. I'm at 3. I'm looking for 1. 1 would be less than 3, so go to the left. Boom, I found it. So that took me, I had to get to the third, I had to check 3 nodes to get to 1. Now if I had 5, 3, 7, 9, let's say 1 was way down here, it's a little sloppy. But in a linked list, if I had a list of numbers and I had to search for them, I have to go through every single node to find 1. Let's say 1 was at the very end. In a sense, 1 is at the very end, because this here is the end of the list, or the tree. In linked list, the end I would have to check all these nodes before I get to 1. So with the tree, it kind of divides that up, says, hey, if it's smaller, go to the left, if it's larger, go to the right.